this video, we'll be going over how to create frequency distributions from a data set, quantitative data set at that. So before we can get going, we have to first organize our data into what's called classes or groups. To do that, we're going to look at something called class limits, midpoints, class boundaries. These are different ways of grouping our data. And then our counts could either be frequency, a relative frequency, or a cumulative frequency. All right, to get going, we're first going to need to calculate what's called the class width. And the formula for class width is just the maximum number in your sample minus the minimum number in your sample divided by the number of groups you want, the number of classes. Okay, so let's go back to the data set in this homework example and use this formula to figure out what the class width is. All right, so it's a little bit tiny. Hopefully you can see it okay. Looking at our data set over here, the minimum number is 30 and the maximum number is 512. So that means our class width is going to equal 512 minus 30 divided by 6. And one quick note, whatever number we get here, we're going to want to round up at the end because we need it to be an integer, we need it to be a whole number, and we need it to be at least this number. So in other words, if we get an answer like 40.1, we'd round it up to 41. Or if we get an answer like 37.2, we would round it up to 38. I hope that makes sense. Let's do this example. So here, 512 minus 30 divided by 6. Let's take out a calculator. 512 minus 30, I'll hit enter. I get 42, divide that answer by 6, and I get 80.333, etc. Okay, so this gives me 80.33. And again, I want to round it up. No matter what I get, I'm going to round this number up. And that would give me a class width. So my class width is actually 81. All right, next. In order to construct the frequency table, we're going to want to do, let's start off with what's called the class limits. And that's what's being asked about over here on the homework. So in order to figure out the class limits, so with class limits, there's going to be a lower limit and an upper limit. Okay. The lower limit is going to be the minimum of our data set, which we already figured out was 30. Okay. Next, what you're going to do is you're going to take that class width that we just calculated, which we calculated to be 81, and add it to the 30. So let's see, 30 plus 81 gives you 111. Make sure I'm right there, yeah, 81. Okay, good. All right, that's going to be the start of the next class. And then again, add 81 again, and you get 192. Add 81 again, and you get 273. Hopefully I'm calculating these correctly. Add 81 again, and you get 354. And we want a total of 6 groups, so let me add 81 one more time, and we get 435. All right. Now, the upper limits are just going to be one less than the lower limit of the next group. So since we see here that the second group starts at 111, our first group is going to end at 110. Okay, similarly, the next group is going to end at 191. The next group is going to end at 272. And then 353. Then 434. Okay, what about this last one? Well, if you're noticing here, each of these also have a difference of 81, whatever the class width is. So if I just add 81 again, that will give me the last upper limit. Let's see, so that would give me 515. Okay, let's talk about two more ways in which we can talk about what essentially is going to be the x-axis of our histogram, what we're going to label these groups as. So this was the first method, something called class limits. Another method that's commonly used is something called midpoints, which is just the middle number of your group. Okay, so it's going to be a single number describing the group. So for this first group, 30 to 110. Well, if we just average those two numbers, that will give us the midpoint. So if we do 30 plus 110 and then divide it by 2, that gives me 140. Divided by 2 is just 70. Okay. And then similarly, if we did 111 plus 191 divided by 2, let's take out a calculator. 111 plus 191 divided by 2, and it gives me 151. And by the way, notice we still have a difference of 81 here. That's always going to be the case with these the class widths, is that you can get from one class to the next class just by adding 81 to it. So if you don't want to actually, figure out what the midpoint is, you can just kind of take a shortcut by just adding 81. And that gives me, let's see, 232 is the next group. Add 81 again. That gives me 313. Add 81 again. That gives me, oops, not 4. That gives me 394. And then add 81 again, and it gives me 475. All right. Okay, so the last way in which we can label the x-axis is not actually done in this particular homework question, but I figured just for completeness, let me show it to you. It's something called class boundaries. And again, we're going to have a lower boundary and an upper boundary. All right, so the way the lower boundaries work is you're going to subtract 0.5 from whatever the lower limit is. So if our lower limit's 30, the lower boundary would be 29.5. Okay. The upper boundary, you're just going to add 0.5 to whatever the upper limit is. So 110 plus 0.5 would give you 110.5. Okay. Now this might seem a little bit strange, like why do we have these 0.5s in here? And the reason being is that when ultimately we create a histogram, we don't necessarily want to assume our data is limited to just integers. So what if we have, a number of of 110.43? Which group would that go in? It can't go in it can't go in the 30 to 110 group, and it can't go in the 111 to 191 group. So basically this eliminates all the gaps, and it's why we draw histograms with no gaps between the bars. So even though you may not actually label the axes according to class boundaries, we often construct histograms with class boundaries. All right, so let's keep going. So the next group would actually start at 110.5, and then it would end at 191.5. Okay, and then, so you notice here that wherever the one limit wherever the one upper boundary stops, the next upper boundary begins. Gives me 272.5 minus 353.5, or 2, not minus, sorry. And then 353.5 to 434.5, and then 434.5 to 515.5. And again, that last part's not in your homework, but it was just an interesting, you see it often. All right, so let's move on to the second group of things. So we've covered all of these. We covered basically different ways of labeling the x-axis, different ways to talk about the classes. On this side, it talks about different ways of doing counting. So the first one is just purely a count. How many in our original sample are in each group? And that's called frequency. So let's talk about frequency, relative frequency, and cumulative frequency. Because I've run out of space, I'm just going to copy part of this to bring it over to the next screen. Let's just take the class limits. Okay, So now let's talk about frequency. And by the way, we often use F as our symbol for frequency. Okay, so frequency is just the number that fall in that first group. So what we'd have to do is we'd have to go to the original data set and count how many are in that first group. Okay, so this might be a little bit difficult to see. So we can actually use StatCrunch to help us here. So let's do that. Okay, so going back to the homework, if we click on these this little Windows icon here, we can click to open this in StatCrunch or open it in Excel or just copy the data to the clipboard. I'd rather just open it in StatCrunch, so let's do that. Okay, so here's the data set in StatCrunch. And by the way, StatCrunch can create frequency tables for you, and I'll show you that in a moment, but suppose we wanted to do this manually. The way we'd do it is first we'd want to sort the data. So if I just click on this triangle here, if you just mouse over the column header and just click on the triangle, there's an option to sort ascending, and that's what I want. So it's going to sort the data from the lowest number to the largest number. All right, and this also would make it easier to find the minimum and the maximum that we did at the beginning. What we want to do is we want to find the number of observations that are in our first class. And remember, our first class goes from, hold up, let me look. It went from 30 to 110. So let's see, this 30, the 35, the 37, and the 80 are in that first group. So the first group has a frequency of 4. The next group goes from 111 to 191. So that would be 1, 2, 3, 4, 5, 6, and that's it. So there's going to be 6 in the second group. All right, so this is taking a little bit of time here. One of the ways we can save ourselves a little bit of time on counting, though you can certainly do this by hand, is by going into the stat menu and then going into the tables, and we want to create a frequency table. I want to use my first variable, so I'll click variable 1. And I can actually tell it. I know in the end I want frequency, relative frequency, and cumulative frequency. To highlight multiple columns, you can just hit Control and select another thing. All right, I want them to use the groupings, the classes that I've created. So to do that, I'm going to click on something called bin. Bin is just another name for classes. Both Excel and StatCrunch use this term bin. And then I want to tell it, I want to start at 30, because that's the group that I have here. Remember, that's how we started it. We started at the minimum. And then I just tell it my class width, which remember, we calculated the class width to be 81. It is going to write these classes a little bit differently than we did, but I'll show you that in a moment here. Okay, so here we go. Here's our table. Notice that we said the first group went from 30 to 110. And that's really what this says. This is something called interval notation. The square bracket on the left means the number is included, and the parenthesis on the right means the number is not included. So really, if we're just sticking to integers, the first group goes from 30 to 110, and then the next group goes to 111, starts at 111. So this matches up to exactly what we did here. And you see these are the counts that we calculated, 4 in the first group, 6 in the second group, and then it just continued down. So the relative frequencies, the way you calculate those is you just take the frequency and divide by the total number. All right, so looking at our frequency table that we got from StatCrunch, and mind you, we could easily calculate these numbers just by counting however many are in the raw data set, especially after we sorted it in ascending order. I wrote it down in my table here. So here are our frequencies. Here's how many we have in each group. We often denote frequency with lowercase f. All right, so now let's also talk about relative frequency. So the way we calculate relative frequency, and mind you, StatCrunch will give this to you, but I think it's helpful to understand how it's being calculated. You just take the frequency, the count in each group, and divide by the sample size. So little f, lowercase f for frequency, and n for sample size. To figure out the sample size, we can just add up the frequencies, add up the total number of numbers we have in our sample. And if you add these up, you should get 29. All right, so to calculate the relative frequency, you just take the frequency in each group and divide it by 29. So you would do 4 divided by 29, and then get whatever the decimal answer is for that. Rounded to, I think, 3 decimal places is what your homework wants you to do, but just, make sure you follow the directions. 6 divided by 29, 2 divided by 29, 8 divided by 29, etc. And even if we leave it in fractional form, that's still a relative frequency. That's just not the way the homework wanted you to write it. And one of the advantages of putting it in decimal form, so these are what the answers would be in decimal form, is that it would be easy to convert to a percentage. So here we have 0.1379, that would round to 0.138 to 3 decimal places. If we wanted to convert that to a percentage, that would be 13.8%. So this would be 0.138 or 13.8%, and et cetera. You just go down the list and just do the rounding. Make sure you round up if the next number is greater than 5 or down if the next number is less than 5. How you typically do rounding. All right, so cumulative frequency. The way cumulative frequency works, and typically people use a capital F for cumulative frequency, though you don't have to. Cumulative frequency is just the total number of observations in your data set that are in that group or a previous group. So the first group has 4 numbers in it and there are no previous groups. The next group has 6, but we have to add to it the 4 we had before. So that gives you a total of 10. The next group has 2 more, so you add 2 to that 10 and you get 12. The next group has 8 more, so add 8 to the 12 and you get 20. Add 5 more and we get 25. And lastly, our last group would be our sample size, which is 29. So I hope this was helpful for you. From this point, you can easily create histograms by hand or really whatever else you want. Both frequency, relative frequency, and cumulative frequency are pretty common methods of doing histograms. They're pretty common methods that's used for just graphing in general. Cumulative frequency is useful for something called ogive plots. And they're also commonly used, obviously, for frequency tables. All right, I hope that's helpful. And of course, let me know if you have any questions.